All right, so here we are working on the third question of the exam. The third question reads, separation based on molecular weight is carried out through a technique known as gel filtration chromatography, okay, aka size exclusion chromatography. Provide a thorough comparison of it to affinity chromatography. Imagine that you are trying to purify a protein from a complex mixture, a whole cell extract as an example. What type of chromatography would be best to use? Support your answer. All right, so this question is more or less um, kind of two parts. And the first part is really just a comparison between one is a comparison between gel filtration, aka GF chromatography, versus affinity, AFF. Now, the difference between these two is pretty simple and pretty straightforward. So the way that I like to think about it is both of them are similar in that they have these insoluble sugar beads. Now, the difference between them is that gel filtration has small pores within those beads, and within those small pores, proteins can fit. Now, large proteins cannot even enter those pores, in which case they hit the top and they move downward. And they basically bypass those beads. So what that means is large proteins, large out first, and small, and I'm referring to protein size here, small out last. So these will emerge from the column last. Okay, now if you compare that to affinity chromatography, with affinity chromatography what you're going to do is you're going to have a small modification to these beads. And that could be something like a glucose ring or some sort of sugar that you've immobilized on that bead permanently, in which case you're going to be selecting for a protein that has affinity for that molecule. So I'm just going to draw like a Pac-Man type figure here with a complementary kind of mouth for this. So this will fit on there just perfectly, and it will hold on to that basically until you do something to disrupt that interaction. So I compare those two, and I like to compare those two because of the fact that you're looking at a binding interaction versus just kind of a progression through the column. So my comparison, to put it succinctly, even though I know that I asked for a thorough comparison, a succinct comparison is affinity chromatography depends on binding of a protein to a ligand, whereas gel filtration chromatography relies on a protein's capacity or ability to enter a small pore. Okay. Now the second part of this question, the second part is, well, really asking more of a kind of experimental question. You're trying to purify a protein from a complex mixture. What type of chromatography would be best? And I'll accept a range of answers, but I really kind of wanted you to focus in on, or I didn't want you to focus in on, but I gave you the option here to basically compare and contrast not gluten-free, gel filtration chromatography and affinity chromatography. So selecting between those two, what would be best? Well, the best one to do between those two would be affinity chromatography. So affinity, sorry, I lost my cursor there. Affinity versus gel filtration, well, it's going to be affinity due to the fact that, again, you're able to select for a specific binding function or ability. One of the things that I think about when it comes to loading a whole cell extract on a gel filtration chromatography column is with gel filtration, you've got, let's just say you've got, it's reasonable to have a protein that has a mass of 60.1 kilodaltons. And in that same mixture, you have a protein that's 60.12 kilodaltons. You have a protein that's 60.2 kilodaltons, 60.3 kilodaltons, and I could go on and on. These discrepancies and these differences between protein sizes are going to be very, very close when you're dealing with a untreated whole cell extract, in which case all of these proteins, when you run them on a gel, it's going to appear like this. These are supposed to be my individual bands. And I'm sorry, they're not the exact same width or anything like that, but um, your ability to select one of those single bands or select a protein from this mixture, it's very, very difficult and virtually impossible. And gel filtration will give you one fraction that has proteins that are 60, 61, 62, 63, 64, 65 kilodaltons, and it's not going to give you great separation. Whereas affinity chromatography, you're selecting for something that this protein does. For instance, if you're trying to characterize a protein that is involved in glucose metabolism, you know that that protein has the ability to bind to glucose. So you don't need to worry about or mess with hemoglobin and myoglobin or any other protein. What you need to focus in on is proteins that bind to glucose. So affinity chromatography is going to be much better. Now, if you were to compare affinity um, affinity versus, say, ion exchange chromatography, that's a discussion worth having. So affinity versus IEX, ion exchange chromatography, I think there's a reasonable case for either one of these. It all kind of depends on what you know about that protein. Ion exchange chromatography is a great way to take a whole cell extract and select for half of the proteins in there. Because, or maybe not clear cut half, but you'll be able to distinguish between those that are positively charged and those that are negatively charged. And you could basically have a series of fractions where each of these independent proteins kind of separate out from one another. So you have a very dramatic kind of division. Okay, so what I'm looking for here is, and the easiest answer is going to be for part 2, affinity versus gel filtration, affinity. And your reason would be you're selecting for a specific activity or your specific function or something like that. Now, affinity versus ion exchange, what I'm looking for is basically something that supports your answer and that conveys an understanding between one of them. But like I said, there's a reasonable conclusion, or there's, I think, reasonable cases to be made for affinity or ion exchange chromatography. All right, well, thank you very much.